Hello everyone and welcome back. Today we're going to talk about the QRS complex and the T wave. To briefly review, in the last lecture we talked about how the P wave represents the electrical stimulus for atrial contraction. There is a brief pause at the AV node before the electricity is conducted to the ventricles. The pause is represented by the PR segment seen here. So the P wave represents the atrial activity stimulating its contraction, and then the pause of the AV node is represented by the PR segment. Today we're going to talk about the QRS interval followed by the T wave, which is the repolarization. The QRS complex represents the electrical stimulus of the ventricle. Since the ventricle is so thick compared to the atria, the amplitude of the QRS will be large. Also, since the His-Purkinje system is insulated, it conducts rapidly. Therefore, the length of time will be short. So one would expect the QRS to be narrow since it is fast, and big since it represents the bulk of cardiac muscle tissue. This is important because if the QRS is wide, it implies that the conduction is not proceeding through the normal His-Purkinje system. If the electricity leaves the rapidly conducting system, similar to a highway, so if you imagine this His-Purkinje system here going down, and these are the most rapid areas of conduction. If there's a block and it has to leave that, then it'll conduct in the myocardium on a cell-to-cell basis, and that'll be much slower. So your usual QRS will be much wider. Take a look at this graphic representation of the direction and magnitude of ventricular repolarization. So we're going to be looking at this right here. As the QRS complex proceeds down the ventricle, it proceeds in this direction and magnitude. So if we imagine little arrows coming out like this, proceeding along, the different leads will detect the direction and magnitude of those forces. So lead 1 will see, and lead 1 is going in this direction here. Lead 1 will see first, it'll be positive, and then as it crosses the y-axis here, it'll then become negative. So lead 1 will be positive, and then negative. AVF is from up to down. It'll start off negative, cross the x-axis and become positive for most of it, cross the x-axis again and become negative. So that's why you get these quick QRS here. And each lead will look a little bit differently, but overall they should be narrow and have a high magnitude as that electrical conduction proceeds down the His-Purkinje system. Following depolarization, myocardium has to prepare for the next depolarization by repolarizing itself. So it has to reset the ion channels in the format so that it's ready for the next impulse. The ST segment followed by the T wave represents that period of time where the ventricle is preparing for the next P wave and depolarization for the QRS complex. So let's review some general rules. If the QRS is wider than expected for age, this often represents disease in the conduction system, or the conduction is occurring outside of the usual His-Purkinje system. Think of the His-Purkinje system as a highway and the myocardium as the back streets. The electricity can shoot down the highway at high speeds, but when it gets on the back roads, it has to slow down for cell-to-cell conduction one at a time. Since the cell-to-cell conduction is slower, this will lengthen your QRS complex, giving the EKG appearance of having a wide QRS. So if you have a wide QRS complex, that implies that the ventricular myocardium is not being depolarized in the usual way down the His-Purkinje system, and is actually proceeding with cell-to-cell depolarization outside of that system. So let's review what we know so far. Here is the 12-lead EKG. We know that when we look at this, we're going to look at lead 1 for a P wave, make sure it's upright in lead 1, as well as upright in AVF, and that'll reassure us that this is sinus rhythm. We also can see that the AVR P wave is inverted, and that's also upright in lead 2. The most important is lead 1 and AVF for evaluating for sinus rhythm. We also look at the QRS complexes, make sure that they are narrow. If they are wide, that implies that it is not proceeding down the His-Purkinje system and that it is proceeding in cell-to-cell depolarization, which is a sign that there is something wrong and is not going down the usual pathway. And then we also look for T waves after every QRS complex, because that indicates that the ventricle is preparing for the next wave of depolarization. And we'll talk about T wave inversions in another talk another time. So right now what I want you to know is how to evaluate for sinus rhythm, how to evaluate for narrow complex, why the ventricular myocardium would have a wide complex QRS, and always to look for T waves succeeding every QRS complex. Thank you, everyone. And tune in next time, we'll talk about how to evaluate the heart rate on an EKG.